In this video, I want to show you guys how to take the derivative of a function using the quotient rule. And when you're going to want to use the quotient rule is when you have some function f of x divided by another function g of x. The formula for this quotient rule is g of x multiplied by the derivative of f of x minus f of x multiplied by the derivative of g of x, all divided by g of x squared. So from here we're going to go over a few examples. Our first one is going to be f of x is equal to x squared divided by 3x minus 1. And if we look up here, our top function, x squared, is going to be equal to our f of x. And our lower function down here, or our denominator, is going to be equal to our g of x. So to find the derivative of f of x, or f prime of x, we can just plug these functions into our formula. So g of x, 3x minus 1, times the derivative of f of x, which the derivative of x squared is 2x, minus f of x, which is x squared, times the derivative of g of x, and the derivative of 3x minus 1 is just 3, all divided by g of x squared, so 3x minus 1 squared. So we could further simplify the numerator by multiplying 2x by 3x minus 1 and x squared by 3. But this is a totally sufficient way of writing this derivative. So for our next function, take f of x is equal to 7x plus 4 divided by x squared plus 5. Just like last time, our top will be our f of x, and our bottom function, x squared plus 5, will be our g of x. So in order to take the derivative of f of x, or f prime of x, we will use this formula again. So g of x is x squared plus 5, multiplied by the derivative of f of x, which the derivative of 7x plus 4 is just 7, minus f of x, which is 7x plus 4, multiplied by the derivative of g of x. Let's put that. The derivative of x squared plus 5 is just 2x. And then we'll divide all of this by g of x squared, or x squared plus 5 squared. Again, we could simplify the numerator by distributing the 7 to x squared plus 5 and distributing the 2x to 7x plus 4. But again, this is a completely valid way of representing the derivative of this function.